Alright, so section 8.3, this is the last of our 3 standards from this particular unit. We have done one, and it's been a long time ago, and I know as long as it's been broken up. Quick review. Our first standard, remember, talked about domain, range, relations, and functions. Okay, that's something that you're going to want to go back and review so you are ready for next week's assessment with that. You understand what domain and range is. You understand how to tell something is a relation or a function, and you can do it from both a list of ordered pairs and also from a graph. Okay? Last week we spent the entire week graphing using tables, and like I said, from your assessments that you took, I feel like we are in a pretty good spot with that particular idea. Today we're going to start talking about graphing using another concept, and this one is going to be graphing using intercepts. Okay? Now, first thing we need to do is define what our intercepts are, but I want to explain a little bit of a difference between this. When I ask you to graph using a table, which is your second standard, I am always going to ask you to graph using a table of at least 5 values. 5 values is the minimum. Okay, you can definitely go over that if you'd like to, but anytime we ask you to graph using tables, we're going to ask you to graph using 5 points. We're going to explore over the rest of this unit, and then also unit number 7 or 8 or wherever we're heading into. I think this is 7A, so we're going into 7B. We're also going to look at other ways to be able to graph functions that don't require 5 values. Okay? Because ultimately, if everything we graph in pre-algebra is a line, how many points do you need to be able to draw a line? You need 2. Okay? So what we're going to investigate in section 8.3 and then also in section 8.5 and 8.6, which is the second half of this unit, ways that we can shortcut graphing from tables. Now that doesn't mean that we're going to eliminate tables and never use them, because graphing using tables is something that's going to come back when you get into Algebra 1, because not everything's going to be linear. And if it's not all linear, you're not going to be able to draw it just by using 2 points. So that's why we start with that in pre-algebra, even though some people are like, that's the most time-consuming one. That's the strategy that can never really leave us. We always have to know how to graph using tables. These other ways are shortcut ways, which are great if the function matches that idea. If it doesn't, then I got to go back and still graph using tables. Okay? So, today we're going to talk about graphing using intercepts. So we need to begin by defining what is our x-intercept and what is our y-intercept. Okay? So our x-intercept is this. This is the x-coordinate of a point where a line crosses the x-axis. Now, one quick thing to note, well, a couple quick things, and I'm going to draw a picture up here to help illustrate this a little bit. If I were to give you the coordinate plane and I gave you a line that was graphed on it, okay, we're going to focus today on those points on where it crosses the x and the y axis. Okay? So, I don't have a scale up here, but let's say for right now that this is the ordered pair of 3, 0. And this ordered pair right here is the ordered pair of 0, 8. Okay? If we're looking for the x-intercept, it says it's the x-coordinate of a point where the line crosses the x-axis. So again, we're going to focus on these 2 ideas right here. This is an ordered pair, and so one thing that we need to be aware of is if I'm asking you for the x-intercept, it should only be a number. It should not be an ordered pair. So we're not going to say that in this problem that the x-intercept is 3, 0, okay? what we're going to be able to say in this problem, by looking at this particular picture, is the x-intercept is 3. That's it. You don't need to add in the 0 portion of it. You might say, well, why? Because if you are on the x-axis, we talked about this way back at the very beginning of this unit. If you are on the x-axis, what do you know about every ordered pair on that axis? What do they all have in common? What's all 0? All of the y values are 0. We talked about that's how you know when a point is on the x-axis. If the y-coordinate is 0, it meant it was on the x-axis. So if I'm telling you it's the x-intercept, then I'm already telling you that your y value must be equal to 0. That's why we're not going to give those as ordered pairs. We're simply going to say that the x-intercept is 3. Okay? Now, y-intercept, not going to be very hard to define this because it's the exact same idea, but now we're talking about where it crosses the y-axis. So this is now the y-coordinate of a point where a line crosses the y-axis. So again, if we go back to that graph that I've got sketched over there to the right, we look on the y-axis and we can see that there's the ordered pair of 0, 8. That's the point of where it crosses the y-axis at. But what we're going to be able to say from this information right here is the y-intercept is 8. Again, there is no mention of that value of 0 for your x. Why? Because it's implied to be a 0. If you are on the y-axis, the only way that you can be on the y-axis is if the x value in those problems is equal to 0. Okay, and I want to emphasize that because when we get to example 1a, b, c, and d, they're going to ask us to find intercepts. Well, if they give you a graph, finding intercepts is a piece of cake. Just look at it and tell me what they are. But if they don't give you a graph and they actually ask you to find them, which is the bulk of what this lesson is going to be about, you need to be able to know how to find an x and a y intercept from an equation. That's the key idea we're looking for here. Okay? So, those are our two definitions. Questions on either one of those so far? Alright, then let's slide down to example number 1a. It says we're going to find the intercepts of each equation. Okay? And it's implying within this verbiage as the directions are written, that means that you are finding both the x-intercept and the y-intercept. Now, again, if I gave you a graph of this, you're just looking at the graph, you're looking at the x-axis, where does it cross? Looking at the y-axis, where does it cross? But I give you an equation, you've got to know a little bit more about this. Okay, so there's going to be two parts to this problem here. Alright? So, the first thing we're going to begin by doing is find your x-intercept. Okay? Now you might say, how do I find an x-intercept? Well, you got to know where they're at and what it means in order to find an x-intercept. So if I'm looking for my x-intercept, we said we're looking for the x-coordinate of where it crosses the the x-axis. So you don't know what the x value is in that problem. Okay, because if you did, that would be the x-intercept. But here's the thing. You do know what your y value should be for the first half of this problem. What should it be? If you're looking for your x-intercept, just got done talking about this with the pictures. If You're looking for your x-intercept. Meaning where it crosses the x-axis at, what must your y value be? It must be 0. Because that's the only place where it's going to cross the x-axis at, isn't it? So when we're finding the x-intercept, I'm not going to write this every time. What you're going to do is you are going to let y equal 0. Because by making y 0, you're forcing that to be on the x-axis, which is what you're looking for. You're looking for where that line crosses the x-intercept, or sorry, the x-axis at. So we're going to take this equation, and we're going to copy it down. The only thing we're going to do is we're going to replace the variable y with 0. So I have 2x minus 5 times 0 equals negative 10. So you're going to notice what we did is we took an equation that was in two variables. We've talked about what that meant last week. We took an equation that was in two variables, and by replacing y with 0, you made an equation with only one variable, which you can now solve for. Okay? So we're going to begin by simplifying the left-hand side. 2x is going to stay as 2x. Okay? What do we know 5 times 0 is, though? We know it's 0. And that's equal to a negative 10. Okay, you can simplify even more on the left-hand side. What's 2x minus 0? What's 2x minus 0? 2x. Okay? So this now just becomes 2x equals negative 10. Again, all we had to do is simplify on that side. Okay, and now we can solve for x. What do you got to do to solve this equation for x now? You got to divide each side by 2. And when you divide by 2, we get x to be equal to negative 5. This right here is your x-intercept. If I were to draw this graph, which I'm not asking you to yet, but if I were to draw that graph, you know that it's going to cross the x-axis at negative 5. Because when x is negative 5, y is 0, because that's the only values that make that equation true, and that must mean that it is a point that is on my line. Okay? Alright, now I told you there's two parts to each of these. It says find the intercepts. You only found one at this point. So the next thing we need to be able to do is we need to be able to find our y-intercept. Okay? Now, in order to find the y-intercept, we need to find the value where it crosses the y-axis at. What do we know about all the values that are on the y-axis, though? The x value is 0. So the first thing we're going to do is now you're going to let x equal 0. And when you work through that, you're going to copy it down and do exactly what we did before. Okay, except now again we're replacing the variable of x with it. So we have 2 times 0 minus 5y equals negative 10. Again, we're going to just begin with a couple things that are simplifying on the left-hand side. We know that 2 times 0 is 0. Minus 5y equals negative 10. Again, let's simplify that. What's 0 minus 5y? Not 5y, but negative 5y. So negative 5y is now equal to negative 10. And then you're going to undo your multiplication with division like we always do, divide each side by negative 5. And when we do that, the y value turns out to have to be 2. And again, this was what y was when x was 0. So this value right here represents your y-intercept. And for our first sets of problems, that's all it's going to ask us to do. Find your intercepts. Now, here's the big thing. Our 4 examples that I gave you today are all very similar in the fact that the x's and the y's are on the same side of the equation. Okay, but here's what I'm going to tell you. I don't care what your equation looks like. Okay, so later on down the road, ladies and gentlemen, we'll take a look at an equation like this, where your variable and constant are on one side and the y's on the other. And later on, you'll take a look at equations that look like this. Okay? Correct. You don't change what you do. If I ask you to find the x-intercept right here, what are you going to do? Let y be 0, and then solve for x. Okay, if I want you to find the x-intercept here, what are you going to do? Let x be 0, and solve for y. Or sorry, let y be 0 and solve for x. So the form of the equation does not change. But sometimes people get thrown off because we change what the equation looks like. Okay? You need to know that in order to find an x-intercept, the first and only step is to let y be 0, solve for x. To find the y-intercept, let x be 0, solve for y. That's it. Okay? So, I'd like you to go ahead and work through example 1b for me, please. Find both your x and your y-intercept. We only got about 3 minutes left here, so we will start back 7th period by checking those two values.